we will kind of wrap things up in the chapter from the chapter on Wednesday, and begin to review, and then on Thursday we'll continue to review for the first half of the chapter test. So sections 2-1 to 2-3 test on Friday. You actually have no homework over the 3-day weekend, which I think I could count on like my one hand how many days throughout the year you will have no homework. Right, Garrett? Very true. Yeah.
I hear Christmas break. We don't have any.
So it ends up working out that in both my honors classes, I'm giving tests on Friday, and neither class has homework over the weekend. So, yay for you guys. I have 5 class sets of test to grade, but you know.
That happened once.
So what she's saying is we're pushing hard.
Hey.
Yeah. Gonna get there.
We're going in hard.
That happened once last year.
So Reese is going to talk about number 13 with the long division problems. Yep. Yeah. Yep.
Do you have any inside scoop on Venus for Friday?
The inside scoop. I'm afraid I can't expose that.
Really?
It's classified.
Please.
It's classified. I can't expose
Is it like some
It'll clear.
like? Do I have to go and buy
Here it
stuff
is.
for this thing?
All right, ladies and gentlemen, up here, please looking at your problem number 13.
Indeed. But like,
I mean, yes.
but is it like area?
So you have the equation and you first have to figure out what you can multiply by. Multiply 4x by to get 4x cubed, and that's x squared. So when you multiply x squared by 4x plus 5, you get 4x cubed plus 5x squared. Then you subtract to get negative 12x squared, and you bring down to negative 11x, and then you repeat until you get f of x equals 4x plus 5 times x squared minus 3x plus 1 with no remainder.
So when it has a remainder of 0, Reese, what does that mean?
What?
So if you get a remainder of 0, what does that mean about what you divided with, the 4x plus 5? Or is that 3? That's 3.
It's a fact.
It's a factor. Yeah, so that means it's a factor, and it's also an intercept. Yeah. Nice job, Reese. Any questions on 13? Nice. So if you get a remainder of 0, that means what you divided with is a factor, but it's also an x-intercept, or a 0. So remainder of 0 means it is a 0 on your graph.
Oh, I totally. What's the theme for Friday? I forgot.
Can't expose that information.
Carrie, if you need to zoom it out, if you just twist the black knob toward the classroom, it'll zoom it out a little bit.
Ah, that was more than a little bit.
I only have this one side. I was gonna ask you about this one. I didn't care. That was one of the worst problems.
So the problem is 8x plus 8 plus 6x cubed plus 10x squared divided by 2x plus 1. I just rewrote that so that it would go down exponentially to 6x cubed plus 10x squared plus x plus 8. And then I added a 0x as a placeholder. So when you start this, to get 6x cubed, you have to multiply 2x squared by 3x. So you do that, bingo bango. You're going down, you get 10x squared minus 2x, bring down the 8. 2x squared goes into 10x squared 5 times. So you do that, bingo bango. You get negative 2x plus 3, and that I just changed that to negative 1 times 2x minus 3. And then that equals 3x plus 5 minus 2x minus 3 is over 2x squared plus 1. And then I made a sorry attempt to write that in the f of x form. I don't think that's right, but
So the back of the book, if you were checking your answers in the back of the book, they do write the answers a little differently, and that's this what Carrie has up here. They take the remainder and place it over the divisor, and that's really how you wrote the remainder when you would have did long division back and forth in 5th grade. However, we are going to write it like the second option that he has down here, where you have your divisor, your quotient, and then your remainder being added or subtracted in the back. So yes, the back of the book writes it slightly differently. It means the same thing, but we will write it this way because our goal then would be to kind of continue to factor and break it down further if possible. Nice job, Gary. You're good.
Okay.
Good.
Yes, sir.
That's what drip.
Respect the drip.
Respect the drip, Karen.
Respect the drip. Carrie's looking like he's been doing what?
What?
It's dripping around.
He's like the.
Yeah. I'm about to hit the links up.
Looking really
That'd be the worst day possible for golf.
Yeah.
So he's gonna chuck the jacket out of your face and.
I was in touch now. It wasn't.
All right, just kind of going over questions 7 and 8. So the first couple questions we're asking you to kind of fill in the blank. Number 7 says you divide the polynomial by x minus 4 and obtain a remainder of 7. And then it says, what is f of 4? So you divide by x minus 4 and you get a remainder of 7. So you're dividing by x minus 4. You go through all the jazz. The remainder is 7. The question is, what does f of 4 mean? What is it equal to? So this is number 7. If you divide by x minus 4, what is the x equal to, Colin? 4. Yeah, so if this is a factor, I could write it as x equals 4 as an intercept. So that means f of 4 is equal to, not 0, because the remainder isn't 0, but it's equal to 7. So whatever you get down here actually creates a point on your graph, because you're dividing by a number, which actually represents your x value. Your answer is your y. Your remainder is y. So if I get a remainder of 0, it means we have an x-intercept. But if I get a remainder of any other value, it means that's just the y value based off of whatever x we divided with. So this is an ordered pair on the graph. It's a point on the graph. So a remainder isn't like useless. A remainder actually means something with respect to the graph. So it would create my y value for whatever x value I divided with. The second question on there says, what value should you write in the circle to check whether x minus 3 is a factor of the problem, blah, 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 blah. And then I had a little circle out there. And essentially, it's kind of asking you the same question. If x minus 3 is a factor, what would the 0 be? Or what would the x value be? Dylan? 3, yeah. So kind of getting, I know that like the wording of that was a little weird. But if you're dividing by x minus 3 and it's a factor, the 0 is 3. The x-intercept is 3. And you can see that there. So I would have that 3 value. So getting it to kind of correlate between a factor and a 0. They mean the same thing. They can just be written different ways. So x minus 3 is the factor, but x equals 3 would be the 0. So we are going to talk about synthetic division today, which I think you'll like. If you didn't love long division as much as I do, in your notes, we're continuing with section 2.3. So if you can turn to section 2.3, still talking about real zeros, but looking at synthetic division. Let's go, ladies and gentlemen. You guys are very chatty today. Come on, section 2.3. Good to go. Chillin'? You're ready. Chillin'. All right, so we're going to talk about synthetic division. Dylan, if something is synthetic, another word for synthetic is? Made. Okay, made by a person, which generally means that it is fake, it's not natural, it's not from cotton. So essentially it's like we think of it as fake. So synthetic division is fake division. So it says synthetic division is a shortcut for long division. Yay, you guys like shortcuts. So yay for a shortcut.
Period.
But there is a big if, and I made that if uppercase. And that if is because it only pertains to one form. And the only way that we can use long division is if our divisor is in the form x minus k, which means it must be linear. If the divisor is not linear, then I cannot use synthetic division. So any of the problems that ask you to divide by like x squared plus 5, like the last couple of problems you were dividing by x squared, you cannot use synthetic division for it. It doesn't work. But if you were dividing by x minus 3, that's linear, you can divide. It's okay to divide with anything that's linear. So shortcut for long division only when the divisor is in the form x minus k. So the k would represent this 3 value. That would represent your x-intercept, or your 0, whichever way you want to think of it. So we have the first example here, and we have 9x cubed minus 16x minus 18x squared plus 32. First off, without doing any of the problem, what do you notice about the polynomial that's on the top? Eric?
It's not in order.
It's not in order. Every polynomial must be in descending order. So I'm just going to rearrange this so that it's in descending order. So when you use division, whether it's long division or synthetic division, the polynomial must be in descending order. So we are going to set this up, and it's going to look totally different than long division. So we're not using a division bar. We will make a little kind of, I don't know, box in a way, like a big L.
Ew.
On the outside of the L, sitting right here, that is our k value. So if I'm dividing by x minus 2, that's my factor, but what's the actual number that you're dividing by, Dylan? A 2. So here, x minus 2, my k value is really 2. Because the factor could be written as an intercept or a point or a 0, however you want to think about it. So we're dividing by x minus 2, but the 2 goes outside. Next to the 2, we're going to write all the coefficients of our polynomial in order. So that's why we need to rearrange them, because the polynomial has to be in descending order. So just the coefficients, we're not worried about x, which is why synthetic division is nice. You don't have to worry about any of the x's. So we're taking the 9, the negative 18, negative 16, and 32. Extend that a little bit there. So we're using all the coefficients, the numbers, just like the quadratic formula. The quadratic formula takes the x's out of the problem and just uses the numbers. So it's the same thing. Underneath the last value, that constant value, we're going to make a little box, and that's going to be our remainder box. So the number outside is what we're dividing with. The number that we get at the very end is going to be our remainder. So again, this is fake division. So the way this synthetic division works is for you to always drop the first number. So we're just going to pull that first number down and write it underneath my little L, underneath that horizontal line. The opposite of division is multiplication. And we're going to use multiplication. You're going to take the number in the circle, multiply it by the number down below. So Colin, 2 times 9 is 18. You're moving diagonally and placing the 18 above. And then since this is still fake division, we typically subtract in long division. We are going to add. So we're taking negative 18 plus 18, and underneath we get a 0. So now we're going to do it again. Just like long division, you have to keep on using all the numbers. So we're going to go to the outside number, which is 2, multiply it by the bottom number. 2 times 0 is 0. Always move diagonally to the next spot. And then you add those numbers vertically. So that gives us a negative 16. One more time, because I have one more number. 2 times negative 16, Colin, is negative 32. So again, moving diagonally over. That's supposed to be a 2. And then Colin, 32 plus negative 32 is 0. So if I get a remainder of 0, that means this is a factor or it's a 0, an x-intercept, whatever we divide it by. Questions? So in the first question here, it says, what is the resulting polynomial? The goal of factoring or dividing is to break a polynomial down. So if I started with 9x cubed, my answer, if I truly divided, should have one less exponent, and then it's going, oops, that should be a 2. So that means that would go with x squared. Because dividing is pulling out a power, it's breaking something down. So if we divided, my answer should have less than what we started with. And it's going to have one less power than what you started with. The 0 goes along with the x term because they descend in order. And that means the 16 is just our constant. That's just the number left over. So when I write the resulting polynomial, I would say I have 9x squared. I'm not going to write 0x. And then I would write negative 16. So that is our resulting polynomial. It's what you have left after you divide it. So it would be considered our quotient with long division. That's what we would have left over on the top. We still have that piece left over. It's just left over in a different form. The next question underneath wants you to factor this resulting polynomial completely. So we have 9x squared minus 16. How would you factor that?
Would you just take the square root out?
Yeah. So what would that look like?
3x minus 4, 3x plus 4.
Perfect. So that is the difference of perfect squares, and it continues to factor as 3x minus 4 and 3x plus 4. The last question says, what are the zeros of the polynomial? Zeros are the same things as x-intercepts, are the same things as factors. I use a factor to find a 0. So what would my zeros be? I have 3 of them. Hannah, what would 2 of the zeros be? So solve these 2, because that gives us zeros.
Oh, 4 over 3.
4 over 3,
Negative 4 over 3.
negative 4 over 3. What's the other 0? It's 2. It's a 0 because we started with 2. That's what we divided through the problem. We got a remainder of 0. So you can't forget about that because I still proved or shown that it was a 0 by getting a remainder of 0. So even though I didn't get it from the leftover equation, we still got it from dividing it out. So when you get a remainder of 0, we're going to start talking about completely factoring problems to get all the answers so that we know all the x-intercepts. So dividing with synthetic division is another way of factoring. It's just you're factoring out a problem a little differently. Questions? So the next one, we're going to try this again so that you feel a little more comfortable with this synthetic division. So use synthetic division to divide x to the 4th minus 10x squared minus 2x plus 4. We're dividing it by x plus 3. And then it says write your answer as a polynomial. Is x plus 3 a factor? So starting on the outside, we got a little circle here. Make yourself a big L. Emma, what number goes in the circle? What are we dividing with? So we're dividing by the x plus 3. That means what number goes over here? Would you say? not a 3. Because if I set this equal to 0, to get x by itself, it would be a negative 3. So we're dividing with a negative 3. So x plus 3 is a factor, but my actual x value is negative 3. What are the coefficients that go across? Be really careful. So what goes across next to the negative 3? Lauren, you know what coefficients we're going to place on the top?
1, and negative 10, negative 2,
She's really close. You should miss it. So what's that original polynomial missing? Huh?
0.
It's missing a 0, x cubed. It doesn't have an x cubed term. It skipped over x cubed. And we cannot skip over any exponents, any powers. Each one needs to be represented. So with the long division, we plug those zeros in for any power that wasn't there. We have to do the same thing for the synthetic division. So I have an x to the 4th. I need a space for x cubed. And then I have x squared, x, and then the number. Underneath that last number is where our little box goes for the remainder. So make sure you're looking at your powers. Is each power represented? If it isn't, then the problem changes from being something to the 4th, and the synthetic division actually thinks it's a cubed problem. So everything needs to be represented. So see if you can drop the first number down and try and use the synthetic division process. So you're multiplying by the number outside, moving diagonal, and then adding. So Josh, if we combine vertically, 0 and negative 3 make?
0. Or wait, say that again. Oh, negative 3.
Negative 3. Negative 3 times negative 3 is 9. And you combine negative 10 and 9 together,
Negative 1.
negative 1. And then negative 3 and negative 1?
Positive 4. Oh, positive 3. I know what I'm doing.
Okay. Negative 2 plus 3 is?
Negative 2 plus 3 is 1.
1. And then this makes negative 3. And when you add them together, you get?
Oh, sorry. I'm not thinking. Sorry. Don't call me.
Okay.
I'm asleep.
So let's see, it says write your answer as a polynomial, so we'll start off with that first. My original polynomial is equal to, I have a 1, a negative 3, a negative 1, and a 1. How would I write that as a polynomial?
You do x cubed minus 3x squared minus x plus 1.
Excellent. So that's my resulting polynomial. If I started with a power of 4 and we divided, then my answer should have 1 less power. We also divided, so I'm going to write what I divided by in front. We're going to write it the same way we did with long division. And then the remainder is last. So my answer should still look the same as long division. We're just getting it a different way. So that would be my answer written as a polynomial. If I multiplied this out and then added the extra 1, I should be able to get back to the original problem. Is x plus 3 a factor of the original polynomial, Dylan? Why not?
Because there's a remainder.
Right. So no, it's not a factor because there's a remainder. But this remainder is a point on the graph. So I could say that at negative 3, we have a point at 1. That's what the remainder actually means. So the number I divided with in the circle gives me a y value of 1. So technically, you could divide like 10 times, plot 10 points, and then you have a graph without using a calculator. Or you can make a T-chart too. I mean, this is way better than a T-chart. Yeah, why would you want a T-chart or a calculator?
Yeah.
Questions? So I believe the remainder theorem, there it is. So again, no, we're not proving this. We will do some proofs throughout the year, but we're not going to prove this. The remainder theorem says if a polynomial, any polynomial f of x, is divided by x minus k, so like x minus 2, like the first problem, then the remainder can be written as r equals f of k. So I could write this remainder as 1 equals f of negative 3. Or I could write it as an ordered pair. But whatever that remainder is, I'll just flip it around because I could write it the other way. It creates an ordered pair on your graph, and that's the remainder theorem. So your remainder is related to the graph. It's not just a random value. Questions? So the problem underneath is like a 2-part problem. Nope, 1-part problem, I guess. We're going to do it 2 ways, though. So it says to use the remainder theorem to evaluate the function at x equals negative 2. How would you evaluate a function at x equals negative 2? Think back, like, what does evaluate mean? Yeah, solve by using the equation or the function. How am I going to solve? Yeah, we're going to take this negative 2 and we're going to plug it in for f of x. So this negative 2 becomes my x value. We're going to plug it in. So the remainder theorem says I can have a number and I can maybe get an answer by taking that number and plugging it in. Anytime it says evaluate means find an answer. If they give you an x, that x represents any x in your function. Plug it in and you get out a y value. Garrett, did you get a y?
Yeah, I got 5.
You got 5. Anybody else get 5?
Yes.
So 5 sounds like a good number. We are going to do this again, but we're going to see if we can use synthetic division. So we took the number and we plugged it in for x, because anytime you know what x is, you can plug it in. We're going to also try and do this with this synthetic division just to see what happens. So if x is equal to negative 2, that's the number that goes in your little circle. I could also write that as x plus 2 being my factor. But whatever x is equal to is the number in my factor. Make a little synthetic division chart here. We have a 3, an 8, a 5, and a 7. And then we have our remainder. So if we bring down the 3, multiply and add. Josh, am I allowed to call on you?
Yes, redemption.
Okay. What do you get for a remainder, Josh?
5.
5. What do you notice, Josh?
It's the same as the
Yeah, it's the same thing. So a remainder, again, is the y value. You can find that 2 different ways. Synthetic division is actually the true remainder, but you can plug it in and evaluate it, and you get the same exact thing. So whether you evaluate it by strictly plugging it in, or you like synthetic division, so you use synthetic division, you get the same exact answer. So you can find that answer 2 different ways. So again, like this is what you would have done back in Algebra 1. You did in Algebra 2. You evaluated functions. Now we're evaluating using synthetic division. But the answer means the same thing. Questions? So if you flip the page, we're gonna skip the top problem.
Oh, wow.
I know, right? There's all those decimals. Yeah. I just want to kind of remind you about another theorem that we've kind of been talking about. So the remainder theorem says whatever your remainder is equal to whatever you divided with. So I divided by a -3, my remainder is equal to that. I divided by a -2, my remainder is equal to that. The other part is the factor theorem, and we've been talking about this. A polynomial has a factor if my remainder is 0. So the factor theorem means the remainder is 0. The remainder theorem can be anything, it's just a point on the graph. But if I specifically have a remainder of 0, that means whatever I divided with is a factor, it's also a 0, an x-intercept, any of those words I'm going to use. We've been talking about that since Friday, once we started getting those zeros as remainders. So that's just kind of like a formalized theorem. Again, in math, like somebody notices a pattern and then they create a theorem. And it's kind of like a valid statement, a true statement that we can use. So the last problem on here wants us to take this big polynomial, 2x to the 4th, and it says show that x minus 2 and x plus 3 are factors. How do you know they are factors? So let's start. How do I show that they would be factors? Dylan? So we could plug them both in using synthetic division, or you could plug them both in for x. What would your answer be? Either case, Dylan. What should the remainder be? Either way, a 0. So we're going to use the synthetic division part. And we're going to start with this x minus 2. So to show that it's a factor, one way we can just divide. So we'll just use division. Dylan, what are you dividing by? Because of 2, yeah. So we place a 2 here. Make sure every power is represented. And then we're just dropping the number and multiplying. Okay, so this is what I get after I divide. This is now x cubed, x squared, x, and then my number 9. We are going to do this a second time because it says show that x minus 2 and x plus 3 are factors. However, we are going to take this resulting polynomial that we have, and we're going to use that as our second division. Our goal is to now start breaking these down to try and factor them completely, because that's what part B says, factor the polynomial completely. So if I can take my answer that I just found and use that answer and the second 0, which is a -3. So we're now using the 2, the 11, the 18, and the 9. This is called successive division. Where you divide, you take the answer, and then you continue to divide. We can do this because it was a factor. So it still relates to our original polynomial. If it's a factor in my original polynomial, it's going to be a factor in the new created polynomial. So successive division continues to break down our polynomial. So again, drop the first number, and then multiply. Because both of them are factors, you should get a 0 both times as a remainder. Part B wants you to factor this polynomial completely. What is the remaining polynomial after we divided twice? Dylan?
2x squared plus 5x plus 3.
And how would you factor that, Dylan?
Multiply the 2 and the 6, or the 3,
Yeah.
and 6, and then split it apart to make
2 and 3. So then we have 2x squared plus 2x plus 3x plus 3. We would take out a 2, and then we would take out a positive 3. So we end up with 2, how about a 2x? I missed my x there. And x plus 1. We showed or proved that the original 2 were factors, so I would also have an x minus 2 and an x plus 3. So my polynomial would be equal to these 4 zeros or these 4 factors. So 2 of them we found by dividing. The other 2 we were given, and we proved that they were factors by getting a remainder of 0. So Lauren, what are the 4 real zeros of the function?
-3 halves, -1, 2, and
Excellent. So that is called successive division. We would do that when the power is 4, and you would have 2 zeros so that you can find the remaining 2 zeros. So your homework tonight, the first group is just using synthetic division. The second group of problems, you're asked to factor completely. So that means your remainder should be 0. After you get that remainder of 0, factor and find the final solutions. Have a great day.